So atomic notation is how we represent the atom. And the thing I really want you to know is that it is the opposite to the periodic table. So what we just practiced, where we have the atomic number above and the mass number below, when we write it in atomic notation, all we do is flip it. Okay? And so this is why I really like to use the yellow and green highlighters here, is so that when we look at it again, we can follow it. So the smaller number, the number down the bottom, is the atomic number. The larger number above is the mass number. And the thing on the right is the symbol. Okay? So what element are we looking at right now? Helium. Okay? So as we label this one, okay, the number up the top is the atomic mass. The number below is the atomic number. And the letters over on the right are the symbol for that particular element. Now, there's a reason that I really like atomic notation, because if you're going to go find the number of neutrons now, what do you need to do? You go top number, subtract bottom number, and that gives you the number of neutrons. Okay? So what we've just been practicing on the prior page, we now have another way of representing. So all that you're going to do, we've got some formulas for you. Again, we already know the atomic number is the number of protons. The mass number minus the atomic number gives us the number of neutrons. And because all atoms are neutral, meaning all atoms have no charge, the number of protons and electrons is always the same. So let's start by doing the first one together. Is there a question?
Do you get the formulas in the test?
You get a periodic table in the test. That is all you get in the test. Same as the one that you've been provided already. So when we have a look at calcium, we're going to start with the atomic notation. So number one, the easiest way to start is with the symbol for calcium. So in the right of this box, I'm going to write capital C, lowercase a. And when we look at calcium, we can see that calcium's atomic number is 20. So 20 goes on the bottom left-hand side here. Now, when we talk about the mass of calcium, can someone help me out? It's 40. Do we just give you 40? Yeah? So up the top, we are going to write 40. Now, again, I'll keep my highlighting the same. So green and yellow. And the atomic number here is what we've represented in yellow. The mass number is what we've represented in green. The number of protons and electrons in an atom is going to be equal to the atomic number. And the number of neutrons is what we need to find by subtracting the mass number or subtracting the atomic number from the mass number. So let's start. Atomic number in this case is 20. This means that there are 20 protons and 20 electrons. The mass number in this case is 40. So I'm going to give you a little cheat here. If we know that the atomic number is the same as the number of protons, you could effectively write a minus symbol here, a subtraction sign. 40 minus 20 gives how many neutrons? 20. Let's do one more together, and then I'm going to leave it up to you. So, fluorine. If you look to number 9 on your periodic table, you will find the symbol for fluorine is capital F. The atomic number for fluorine is 9. It is found in the 9th position. And the relative weight, the relative mass of fluorine is 19. Okay? So up the top we write 19. Again, I'm going to follow the conventions of using these same colors once again. And we find that the atomic number for fluorine is 9. This means the number of protons and the number of electrons is also 9. We see that the mass number is 19. And because we go the atomic number, subtract from the mass number, the atomic number and the number of protons is the same. So 19 minus 9 gives us how many neutrons? 10. So your job now, please can you finish this table for me? Now the last three are particularly tricky because you're going to have to go and find these elements using your periodic table. Give it a go.